Force and laws of motion and work done. These chapters are related to NCERT book, chapter 8 and 9. Coming to the topic concept of force. What is force? Force is the push or pull on an object. If an object experience push or pull, so the term force signifies the push or pull will be the force on the same object. So force can be observed when there is a change in the speed or change in the direction, or the shape or size will be changed. Force cannot be seen directly, but it can be experienced. Coming to the next topic, that is the Newton's laws of motion. We have three laws of motion, that is Newton's first law, second law, and third law. First law is also known as the laws of inertia. This states that the object at rest stay will be in the rest, and an object in the motion stay in the motion with the same speed and the same direction until and unless the force applied on it. So the laws of inertia having the example as sudden brake, bus start suddenly, and the sharp turn. Coming to the second law of motion, that is the Newton's second law of motion. This law states that the rate of change of momentum of an object is directly proportional to the force applied on it. Greater will be the force, faster will be the change in the momentum. Same force, less acceleration on the heavy object, and it is having the more on the lighter objects. Examples are when the car is pushed continuously, it gains the speed continuously. Coming to the third law of motion. Third law of motion says that an object experience amount of an object exerts an force on another object, so the second object also exert the equal and opposite amount of force on the first object. That is a force having equal and opposite reaction when it applies a force. Examples are the football, spring balances, walking, gun, and bullets. Here the forces are equal in magnitude and opposite in direction. They act on different object but never on the same object. So the third law says that every action has equal and opposite reaction. Coming to the next topic, that is work done. What is work done? Work done is only experienced when the force causes displacement. The examples are pushing a rock that doesn't move, having the amount of work done is zero. Holding a load without moving also is the amount of work done, having the value zero. But lifting a book or pulling a trolley is an example of work done. Coming to the next topic, that is work done by a constant force. Here, here we assume it as an object is placed on a surface. So if we apply a force on an object, by applying the force, the object also moves in the same direction. So if a constant force is applied on an object, so the object experience a displacement. The amount of displacement will be termed as the amount of displacement experienced by a particular force will provide us the value of work done. So the work done can be represented as force into displacement. F is the force and S is the displacement. The multiplication of force and displacement will give us the work done. Work done can be represented by the unit of joule, as 1 joule can be represented as 1 joule. 1 joule is equal to 1 Newton times 1 meter. That is 1 joule is equal to work done by 1 Newton of force that displaces an object by 1 meter. That is equal to 1 joule. Coming to the next topic, that is the gravitational potential energy. What is gravitational potential energy? Here, when an object is raised to a height, suppose an object is placed on a level. So if an object is raised to a height of h, so here the work done is against the gravity. Work done is stored as a gravitational potential energy. So the gravitational potential energy can be observed when the object is raised to a height and the work is done against the gravity. Here the formula of potential energy can be given as potential energy is equal to mgh. Here m is the mass of the object, g is the gravitational acceleration, that is the acceleration due to gravity, and h is the height. As higher the object, the potential energy will be also higher. So depending upon the level of the object placed on the ground, the potential energy also depends. So higher will be the object, more will be the potential energy. Coming to the next topic, that is the kinetic energy. Kinetic energy is obtained when the object possesses energy due to its motion. That is, kinetic energy can be represented as half mv square. Here m is the mass, v is the velocity of the object. So its formula is kinetic energy is equal to half mv square. The energy can be obtained when the object is in motion. So it possesses the energy, that is the kinetic energy. Now we are going to do some numericals based on the kinetic energy and gravitational potential energy. Here in this question, we have to calculate how fast should a man of 50 kg run so that his kinetic energy will be 625 joule. Here the given datas are given. Mass of man is 50 kg. Kinetic energy possesses by the man will be 625 joule. So as we have discussed, the kinetic energy is equal to half mv square. So after substituting the values here, we obtain what is the velocity of the man. Kinetic energy is given as 625. Half mass is given as 50, and here v square. This is 25 and this will be 25. So v square is equal to 25. So v is equal to 5 meter per second. So in this question, we obtained the velocity of man. That is, v is equal to 5 meter per second. So the answer of this question will be 5 meter per second. Coming to the next question. As this question is a true and false based question, we have to observe this statement. Either it is false or true statement. Let's check it. The potential energy of a body of mass 1 kg kept at a height of 1 meter is 1 joule. So potential energy is given as 1 joule. And as we have learned the formula of gravitational potential energy or potential energy, that is mgh. What is given in the question? Mass is equal to 1 kg. Height is equal to 1 meter. And gravitational potential energy is equal to 1 joule. So potential energy formula is mgh. If we substitute the values are 1 joule. This is the this is the left hand side and this is the right hand side. If we substitute the values of mass, that is 1. G, as for our calculation, we generally take the value of G as 9.8 meter per second square, or for the easier calculation, we generally take the value of G as 10 meter per second square. So here we are taking the value of G as 10 meter per second square. So G is 10 and H is given as 1 meter. So right hand side will be 10 joule, but the left hand side is 1 joule. So left hand side is not equal to right hand side. So the statement, the potential energy of a body of mass 1 kg kept at a height of 1 meter is 1 joule, is a false statement.